Alright, this is day 3 in advanced geometry. Today, in our hierarchy, we discussed parallelograms. So if we want to start filling this information out from what we did last time, the definition of a parallelogram is obviously that it's got two pairs of parallel sides. Right? A parallelogram has two pairs of parallel sides. When it comes to symmetry lines, a parallelogram has no symmetry lines. And when the diagonals do something fancy, they bisect each other. So remember the three things that I was concerned about was, are they perpendicular, do they bisect each other, or are they equal? The diagonals of a parallelogram bisect each other, meaning this blue guy right here just cut that green guy into two equal pieces. And the green guy cut the blue guy into two equal pieces. But notice, they're not the same length, right? Otherwise, this would say they're equal. They do not intersect at a 90. Otherwise, this would say they're perpendicular. All that happens was they cut each other into two equal pieces. And what that means is that this point right here, right, is the midpoint of the blue segment, and it's the midpoint of the green segment, right? They intersect at the midpoints of the segment. So, rock and roll. Here's some other properties that we can use when it comes to parallelograms also. Stuff that you probably learned a long time ago in like maybe 7th grade, that opposite sides of a parallelogram are equal, meaning if this guy is 10, then this guy is 10, and if this guy is 6, and this guy is 6. And this is stuff that we can use in a proof, right? You know, it's like when it comes to justification, it is not the definition of a parallelogram, but it's some properties of a parallelogram, so that's good for us. Also, we know that opposite angles are equal, so angle 1, angle 2, angle 3, and angle 4, right? Opposite angles are equal. So if you pick on angle 1, if it was 80 degrees, then the angle opposite that is 80 degrees, right? Opposite angles are equal. And remember back to a trapezoid that consecutive angles between parallel sides are supplementary. So if this is 80 degrees, then this has to be 100 degrees, right? Because that's a consecutive angle between parallel sides. But, oh, whoa, check this out. So is 1 and 4. They're consecutive angles, and they're between parallel sides now also. Since we got two sets of parallel sides, these have to be supplementary also. And you can see that those make our opposite angles equal, but what ends up happening now is, since you're always between parallel sides, any two consecutive angles are supplementary. Any two consecutive angles are supplementary in a parallelogram because you're always between parallel sides. That's that property of that trapezoid that gets kind of like added some bonus to it because now we're always between parallel sides. So let's try some, wait a minute, here's your hierarchy, what it looks like now, and you know, here's the truth, guys. Basically, this is it. This is all you really have to end up studying for your hierarchy test, because as we'll see next week, that the rest of this stuff, these other three, it all happens with marriages, right? And I'll explain that as we go, but all we have to memorize is basically the top, because the rest is about symmetry lines and diagonals, symmetry lines and diagonals, symmetry lines and diagonals, and obviously the definition. But I want to show you a secret of something that I created of how to remember about the diagonals. With this trick, you will be able to fill out every one of these diagonal blanks when it comes test day. And it all has to do with like a stupid acronym. When you have to memorize a ton of information, you want to come up with a stupid acronym. So, tell me about the diagonals of a kite. They're perpendicular. Doesn't that start with a P? Right? Tell me about the diagonals of a parallelogram. They bisect each other. That starts with a B. And the diagonals of an isosceles trapezoid are equal. And you see how these three things are basically kind of like at the same level. Tell me about the diagonals of a quadrilateral. Nothing fancy, nothing fancy, right? There's nothing to remember up there, so there's nothing fancy, nothing fancy. So here's what I came up with. I want to think of something stupid that starts with a P, a B, and an E, so I can remember that, and it goes from left to right. I just think of peanut butter every day, right? We're going to eat peanut butter every day, and that'll make us a happy person. So that will help you remember about the diagonals. Perpendicular, bisect each other, equal. And then as you'll see when we get things married, right, doesn't a kite and a parallelogram marry each other? So tell me about their diagonals. Well, it's a P and a B put together. The diagonals will perpendicularly bisect each other. And we can marry the parallelogram and the isosceles trapezoid. Its diagonals will bisect each other and be equal. And then finally, the very last marriage is the diagonal of this will perpendicularly bisect each other and be equal. But if you can remember peanut butter every day and where they go, you will have the answer to all the diagonals, because up here is nothing fancy and up there is nothing fancy. So We'll see more about that next week, but peanut butter every day. Very cool to remember. Now let's try some problems here. So have that hierarchy sitting to the side where you can look at stuff about parallelograms, and they want to know, all right, tell me about, let's solve for A. These are all parallelograms because they tell us so up at the top of the paper. Aren't these out of sides, angles, or diagonals? Aren't these side lengths? What do we know about opposite sides of a parallelogram? Well, the hierarchy says that they're equal. So I'll set these two equal to each other. 2a should equal 3a minus 5. So I will subtract 3a over here and get negative a equals negative 5, and then obviously a should equal 5. So I solve for a. Aren't these also opposite sides of a parallelogram? So they should be equal to each other. 2b minus 1 should equal b plus 3. I'll subtract b over here. Add 1 to both sides. And get b equals 4. Good for me, right? So I used a property that opposite sides were equal in a parallelogram. Here, these are angle measures. So what I like to deal with first is opposite angles. Opposite angles are equal. If this is 44 degrees, that's got to be 44 degrees because opposite angles are equal in a parallelogram. Then these are not opposite angles. They are consecutive angles, and any two consecutive angles are supplementary, so this guy's got to be 136 degrees. And then just for fun, this guy's got to be 136 degrees also because opposite angles are equal in a parallelogram. On number 3, they give me information about the diagonals. And what's true is that the diagonals bisect each other. So booyah, booyah, those two are the same. And boom, 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 those two are the same. But remember, both diagonals are not the same length. They just cut each other into two equal pieces. So I can say y plus 1 has to equal 26 because those two dudes have to be the same, meaning y equals 25. I can also say that x minus 2 has got to equal 19, so then x equals 23. Cool. What I'd like you to do is pause the video and do the next 3 problems. Do number 4, number 5, and number 6. And just ask yourself, are these sides, angles, or diagonals? So give the video a pause, give those a try. So here on number 4, these were opposite sides, so you set them equal to each other, and hopefully you got b equals 7 and a equals 2. You can check yourself there. Number 5 I skipped over, and number 6, those were the diagonals because they bisect each other, so I solved and got x equals 4 and y equals 3. On number 5, I definitely know that opposite angles are equal, but this would be a bad idea to like set these two equal to each other right now because this has an x in it, that has a y in it. So I think I would like to pick on these. These are consecutive angles and they're supposed to be supplementary, but since they both have an x in it, that's why I'm picking on them. So I can add these together and set equal to 180 because those are consecutive angles. So 4x has got to equal 172, and then divide by 4, so that would be 43. X equals 43. Then once I know that, I could substitute 43 in for x, and that'd be 129 right there when I punch that in. And now I can set this guy equal to 129. Y plus 9 has got to equal 129, and then y equals 120. So if they have different variables, you want to try to get an equation with the same variables in it. That's a very easy one to solve. Let's keep moving on. It says find the coordinates of the intersection of the diagonals of parallelogram. There's a new symbol, just like triangle symbol, they have that in front of them. There's parallelogram HJKL with the given vertices. So find the intersection of the diagonals. Remember, there's a parallelogram, very ugly one. The diagonals bisect each other. So since that red one cuts the blue one into two equal pieces and the blue one cuts the red one into two equal pieces, they intersect at the midpoints of those segments. And it better be the same midpoint. So since they're telling me it's a parallelogram, all I got to do is find the midpoint of one of these diagonals. So we'll do it like so. We'll say the midpoint of one of the diagonals would be segment HK, right, because they're not in consecutive order. So I will find the midpoint of segment HK, labeled all nice and neat for me. So the way you do that is you can use your cheat sheet and you add your x's together and get 1 plus 6 and divided by 2 over 1 plus 3 over 2. Add your y's together. Bring it down. That would be 7 over 2, and that would be 4 over 2, which can simplify to be 7 over 2 does not simplify, and that is 2 right there. So that is the intersection of the diagonals. It's the midpoint. Because it's a parallelogram, we only have to find one. We know that we'd get that same midpoint if we do it the other way. And over here, same thing. Let's do the midpoint of segment HK, right, which would be one of the diagonals, and get -1 plus 3, right? We're adding these together, and 4 plus -2 over 2. We're adding those together, and that would be -2 over 2 and 2 over 2. Actually, that would be a positive 2, my bad. And that would be 1, 1 is the intersection of the diagonals. So, because they bisect each other, they intersect at the midpoints. Now, if they didn't tell you it was a parallelogram and they said, prove to us that this is a parallelogram, you'd have to find both midpoints, right? And if they were the same, then that would be a parallelogram because the diagonals bisect each other, just like we're going to do on the back side.
Here's what's going on the back side. They say determine if ABCD is a kite, a parallelogram, or an isosceles trapezoid by finding the correct information about its diagonals. So this is where the phrase of peanut butter every day can really help you. Notice how I typed these in order. I went kite, parallelogram, isosceles trapezoid. What order did I kind of put that in? According to the hierarchy. Like straight across, left, right? So tell me what you know about the diagonals of a kite. I'm going to put a P above that real quick. What do you know about parallelogram? Bisect each other, and I just put a B above that. And isosceles trapezoid? Equal. Now what I've done is I've specifically made up these ordered pairs, and there will never be anything in these problems to where it's like, well, sometimes it's equal and they bisect each other, because that can happen. It would be a rectangle then. It's like this is either only a kite, it's only a parallelogram, or it's only an isosceles trapezoid. You with me on that? There's no overlapping. There's not going to be a rhombus come out of this. There's not going to be a rectangle. There's not going to be a square. It's just one of these three things. All we got to do is some algebra to see which one of those three things it is. Kite, perpendicular. What do you need to do algebraically to see if the diagonals are perpendicular? What do you got to find? Slope. Parallelogram. What do you got to find to see if the diagonals bisect each other? Midpoints. And isosceles trapezoid. What do you got to find to see if the diagonals are equal to each other? Distance. There's a slope, there's a midpoint, and there's a distance. Out of those three things, which one do you like to do the least? I agree with distance. I don't like to do that one. Slope's pretty easy for us. We've been doing midpoint's really not that hard. It's just sometimes we accidentally use the minus instead of the plus or something. In distance, I'm going to save it for last. So first thing I like is to check to see if it's a kite. Sound all right? So I'm going to do this. I'm going to organize my work. This is the key to success this chapter, work organization. I'm checking to see if this is a kite. And next to that, I always kind of tell me in my own words what I'm looking for. Would you agree that we're looking to see if these diagonals are perpendicular to each other? I'm a huge fan of now finally highlighting. If you haven't been doing that, I'm not necessarily highlight, but at least circle or underline or something, the diagonals, because this is an optical illusion nightmare when you just keep looking at the same ordered pairs over and over and over and over again. So if you want to highlight, highlight. If you want to circle, circle. But isn't segment AC one of these guys diagonals? And we're wanting to see if they're perpendicular, so what will I find again? Slope. Labeling our work. Slope of segment AC equals. Let's find that. Did you get -5 halves? Cool. Do I need to find the slope of the other diagonal? Yeah. And if they're two fancy words. What are those two words? Opposite reciprocals. We can stop, right? If those are opposite reciprocals, shouldn't those diagonals be perpendicular, which means it will be a kite, because we have no overlapping in these problems. I'm going to guarantee you that. Sound all right? So if we get a slope of 2/5, then we're done with this problem. So I need the slope of segment BD. Let's see what we get. 3 minus 1, negative 2 minus 3, correct? 2/5. Yay for us. Tell me what we know. Did I do that? 2 over negative 5. Right, my bad. Did I get opposite reciprocal slopes? No. Anye for us. Anye. Is that a word? No, it's 2 words. Anye. So is it a kite? Yes or no? Nope, not a kite. I do this. Cross it out. Not a kite. What do you want to try next? Parallelogram. I'm not even going to write that word. I'm going to put that symbol. And then, what do? Bisect each other. How will I find that? Midpoints, right? So I'm going to do the midpoint of segment AC. And this is where you got to watch yourself, because it's adding instead of subtracting this time. I'm going to do the midpoint of segment AC. I'm going to erase my little thing over here because I went in. I'll be all right. That'd be 1 plus 3 over 2, comma, 3 minus 2 over 2. 4 over 2 is 2. 1 over 2, which is 1 over 2. I got 2 1/2 for the midpoint of segment AC. Is that cool with you? Do I have to find the other midpoint? Because I don't know if it's a parallelogram or not. I'm trying to prove that it's a parallelogram, so we got to find the other midpoint. If it turns out to be 2 1/2, then that's yes, it's a parallelogram. If it doesn't, then no, it's not a parallelogram. Midpoints of segment BD. That will equal, is that a positive 1? Let's erase and see. It is a positive 1. Plus 1 over 2, what? And negative 2 plus 1 over 2, what? That equals 2 negative 1/2, right? All right? 2 negative 1/2? Why is it a positive 1/2? Negative 2 plus 1 is negative 1, isn't it? But that's an x value. No wonder. I got that all backwards. My bad. That's what happens when you stand too close to the screen. I apologize for my mistake there. But I couldn't read those ordered pairs very well. I want to do 3 minus 2 over 2, and then 1 plus 3 over 2. Isn't that when we do x's together, y's together? That would be 1/2 2. Correct? My bad. I was standing too close to the screen, couldn't read the ordered pairs very well. That's the same thing? So is it a parallelogram, yes or no? Nope. So we already know what the answer is going to be, right? But you still got to show it. Prove to me that you can use the distance formula. And let's do one distance, and then I'm going to show you the awesomest secret in the world. So I want to test to see if it's an isosceles trap now, by seeing if the diagonals are equal to each other. And let's just find the distance from A to C. I want to show you a nice, neat secret when we're done with this. Distance from A to C. Erase all this stuff I can't see. It's going to be 3 minus 1. God, no it's not. Highlight them. A and C. Yeah, 3 minus 1, my bad. Squared plus negative 2 minus 3 squared. We good with my setup there? Now check this out. I haven't even went any further. Just stop. I want to show you a secret. 3 minus 1. Negative 2 minus 3. Did we do that anywhere else already? Did we happen to do that anywhere else already? The slope formula and the distance formula have the same ingredients in it. Isn't it subtract your x values from each other, subtract your y values from each other? Isn't that what you did, like right here? So do you see these numbers right there in the slope? That's what's got to get squared. Isn't this the 2 that's got to get squared right here? What's 2 squared? 4. And this is negative 5 that's got to get squared, which is 25, sorry. And then you add them together and you get 29. It's the square root of 29. Rock and roll. Now let's find the distance from B to D using my cool shortcut. You don't need to do all that freaking setup because we've already done all the setup over here. What you do is you take your non-reduced slope. I know that's weird at first because we didn't have to reduce the slope, but you take your non-reduced slope. Isn't this the slope that was non-reduced? It didn't need to be reduced in the first place. These are the numbers that are going to be shooting out of the situation. We just got to square them. What's 2 squared? What's negative 5 squared? 25. I got to square them, right? That's because it's got to take those distance, subtract them, and square them, and boom, distance from B to D equals square root of 29. Is this an isosceles trapezoid? Yes or no? Yes. So what we will say is that ABCD is an isosceles trapezoid because ABCD is an isosceles trapezoid because, can anybody tell me what we would say after that? Why do we know that it's an isosceles trapezoid based off all of this work? The diagonals are equal. We just showed that the diagonals are equal. That's the worst case scenario because we had to do all of that work, right? We had to try the kite, it didn't work. We had to try the parallelogram, it didn't work. So it meant that this had to work. Do you have to go in this order? No, you don't. If you want to find, just guess around, it's like, oh, I'm going to see if it's isosceles trapezoid first. Well, I don't care what you do. Label it at the top. Okay, so let's try it again. What do you want to see? Kite? All right, let's try it. Let's see if it's a kite. That means I'll do kite, see if the diagonals are perpendicular. And that would be slope of segment AC. Negative 1 minus 1. I'm moving this guy up here. Don't want you. Over 8 minus 2. Which equals negative 2 over 6, which is negative 1/3. Is that the right slope? Slope of 3 for the other one. Tell me what we got. ABCD is a kite because the diagonals, first tell me about the diagonals, because the diagonals are perpendicular. Then in parentheses, you need to also explain to me why you know the diagonals are perpendicular, and that's because of opposite reciprocal slopes, which you can abbreviate. So you're first telling me what it is. This is a kite. How'd you know that? Because the diagonals are perpendicular. You're telling me on the hierarchy sheet which one of those rules happened. Well, the diagonals are perpendicular. How'd you know that? Opposite reciprocal slopes. Okay? It's worth noting of why on these next two problems, like this one and the next one, I had to change some ordered pairs. A kite, diagonals, they are perpendicular. Other shapes, diagonals can still be perpendicular. It's totally possible for an isosceles trapezoid for its diagonals to be perpendicular. They can intersect at a 90-degree angle. So just proving that diagonals are perpendicular doesn't mean it's a kite. But I'm guaranteeing you, I drew this guy out on a graph. It's a kite. All I'm trying to get you to memorize is that the diagonals of a kite are perpendicular. You can draw a plain old quadrilateral on a graph, and its diagonals could intersect at a 90, right? But the true way to prove that something's a kite is to get two distinct pairs of consecutive sides equal. That's really the only way to prove that something's a kite. One more. Change that ordered pair on 11 to 1, -2 for point C. If it hadn't been changed already. Cool? Go through it. You and pal, I don't care what you try. Give them all a shot. So you can pause the video, get that done. If you tried to see if it was a kite first, you'd go and check the old diagonals. Whoa. Did you get undefined? Those of you that at least did that, did you get undefined for the slope on that? Now, let's pretend that we did want to get the slope that was perpendicular to undefined. What would the slope have to be for it to be perpendicular if that one was undefined? It would have to be 0, because isn't an undefined line slope, or vertical line, have the undefined slope? And aren't horizontal lines perpendicular to it, correct? Didn't happen, so I try parallelogram first. I got 1 3/2 for my first midpoint. I got 1 3/2 again for my second midpoint. So boom, I'm done, brother. ABCD is a parallelogram because the diagonals bisect each other. Sound cool? Just for fun, I'm going to let you watch me. I'm going to do the isosceles trapezoid trick again because we've only done that once, and I think it's worth showing you again. I want to find their distances for isosceles trapezoid. Using the junk that I already did over here. You must use the non-reduced slopes, though. Here's the reduced slope. I hope you realize you can't even use that in there. It's the word undefined. So if I want to find the distance from A to C, I take this guy right here and square him. What would you get? -7 squared. 49. Plus the other guy squared. What's 0 squared? 0, so I don't even need that. Distance from A to C is not the square root of 49. It's 7. Simplify that, right? Down here, you get the distance from B to D. Take the non-reduced, which is this one. It's going to make a difference someday. Okay, the non-reduced one, and square this guy. What would you get? 1 plus 36. And wouldn't you get the square root of 37 out of that situation? And do you see that those diagonals are not equal? It is not an isosceles trapezoid. Last one. What did they give you? What did they give us? Parallelogram. Awesome. So it's the old, what do they give us? Is it dirty? No, it's not dirty. Then we've always got to get in this habit. It's our weakest thing. What are we trying to prove, right? It's like, what are we trying to prove now? What do they want us to prove? 2 triangles congruent. 5 ways to do that. What are those 5 ways again? Side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. Awesome. We have a ton, and I mean a ton, of ways to get this done. Well, let's brainstorm. How could we prove the triangle is congruent? Knowing that we have a parallelogram. We can use the parallel lines, right? We can use parallel lines and then get what from the parallel lines? Angles. And there's also a friend in there. Who's our friend? There's a shared side in there. That's a lot of work. We could do it. Let's think some other methods before we get started. I want to show you the shortest way possible. What else could we do besides using the parallel lines? My question is, do you know anything else about parallelograms? Are opposite sides equal? Yep. What else do you know? Opposite angles are equal. Correct. What else do you know? Consecutive angles are supplementary. Yep. One more thing that you know. Starts with a D. The diagonals bisect. Even though it doesn't have the word property next to it, it's still a major fact. Can't use anything about the diagonals in this problem because there's only one drawn in. You with me? So out of having opposite sides the same, opposite angles the same, consecutive angles supplementary, and diagonals and parallel lines, what do you feel would be the easiest way to go about this? Let's use those opposite sides. What do you think? Should this be the same as this? Yes or no? Step 2. Segment AB is congruent to segment DC. Would I write down the definition of parallelogram for that? If I asked you what the definition of a parallelogram is, would you say that opposite sides are congruent? What is the definition of parallelogram? Two pairs of parallel sides. This is not the definition of a parallelogram. What is it? It's a property, right? So, property of what shape? So, start with this. Parallelogram implies. If we have a parallelogram, that will imply that, what did we just particularly use about that parallelogram? Opposite sides congruent. Does that make sense? The justification? Parallelograms imply that opposite sides are congruent to each other. Neato? Anything else you want to do? Other two sides. Two tick marks, semicolon, segment AD, congruent to segment BC. Same reason, just killed two birds with one stone. Awesome. Do I have enough information to prove the two triangles congruent right now? Nope. Do you see how we used what they gave us, though? They gave us a parallelogram. I used it. Do I have enough information? No. What do you want to do next? Shared side? Cool. We can do it. That's the checklist, baby. How many tick marks? Cool. Segment DB is congruent to segment DB. What's that called again? Just plain old reflexive property? Nice. Why are the triangles congruent? I can tell you that proving two triangles congruent isn't going to go away for a while. All right, we're still going to do it. Question for you. Could I have done this? Angle 1 congruent to angle 4. Could I do that? Give me, and I got to say this didn't happen, right? Give me a reason why angle 1 is congruent to angle 4. Parallelograms imply, my pen froze, opposite angles congruent. Sorry, my pen got all out of whack there. So then boom, boom. Do I have enough information to prove those two triangles congruent? Which way? Side, angle, side, right? Could I have used the parallel lines? Yeah, but it's more steps. It's more steps. It's more steps. Whatever you got to do.